Ladies and gentlemen, please take your seats. Our program is about to begin.
Ladies and gentlemen, our program is about to begin. Please silence your cell phones or place them on vibrate.
أيها السيدات والسادة، سيبدأ البرنامج بعد قليل، لذا نرجو منكم التكرم بالجلوس في مقاعدكم.
Now there is massive amount of opportunities into different industry, edtech, health tech, biotech, and many other areas that are really great opportunities for entrepreneurs to capture. As we live through the pandemic, those kind of shifts create those cracks into different industries that creates opportunities.
The key aspect that I think all of us need right now, which is a key aspect of resilience as well, and that of course is hope. Hope that things will get better, hope that we can make it better as well.
Good evening. Welcome to day 5 of WEP. I hope just earlier today you had the opportunity to taste some of those delightful plankton pastes. If you haven't, too bad. So today, for today's last keynote session of the day, we have Professor Marilyn Brown. And I want to give an introduction to Professor Marilyn Brown, who is currently with us virtually. Professor Marilyn Brown is a Regents professor in the School of Public Policy at the Georgia Institute of Technology, and a joint faculty member at Oak Ridge National Laboratory. At Georgia Tech, she created and co-leads the Climate and Energy Policy Lab and the Master of Sustainable Energy and Environmental Management. Her research focuses on the design and modeling of energy and carbon reduction policies and programs, covering both carbon emissions and sinks, and highlighting opportunities on the customer side of the electric meter. Prior to Georgia Tech, she worked at Oak Ridge National Lab, where she deployed her expertise in scenarios focused on a clean energy future, bringing a fact-based and authoritative perspective to energy sustainability discussions, influencing policy initiatives in the US and around the globe. Focusing on the electric utility industry, Dr. Brown has joined fundamental behavioral and social science principles with economic engineering models. She has demonstrated why energy efficiency and affordability are as essential to energy security as the more traditional dimensions of fuel diversity and import independence. In 2007, Dr. Brown contributed to the IPCC reports that shared the 2007 Nobel Peace Prize. And from 2010 to 2017, she served two terms as a presidential appointee to the board of directors of the Tennessee Valley Authority, the nation's largest public power provider. From 2014 to 2018, she served 2 terms on the U.S. Department of Energy's Electricity Advisory Committee, where she chaired the Smart Grid Subcommittee. She has written 9 books on the clean energy transition, which have been used by researchers and students around the world. And today we'll hear more about her talk and her expertise on these areas. Professor Brown, please.
Thank you very much for that introduction. It's much appreciated. All of those details, you can see that my focus has been largely on the electricity sector and opportunities. So we'll hear more about that in just a minute. The topic of my talk is carbon reduction strategies and their impact on resilience. And it's a pleasure to be here at Cal, though virtually. I was so excited to be able to attend in person, but the pandemic is not allowing that. So next best is this wonderful venue that you've created for online participation. So with that, I'm going to direct us to the next slide. I think that I am in control. Very good. I'd like to introduce you to the subject by marching down sort of the justification for why I am doing what I do, which is to develop localized solutions for carbon reduction. Climate change presents real risks to every country around the world. We all are seeing the unfolding of climate change and its consequences. And tackling those risks head on presents real opportunities. As you heard from the introductory film clips, so many business opportunities and opportunities to enhance our energy systems come alongside with carbon reduction solutions. Addressing climate change at scale will require creativity and innovation. So we're likely to be innovating our way out of this problem. I'm going to start by talking about Project Drawdown, which has pioneered this type of new thinking at the global scale. And I'm going to then end by describing how we in the state of Georgia in the United States have been bringing the drawdown logic to a localized lens. The bottom line is that we need a net zero emissions planet this century by the year 2100. We need to have broken that zero axis at the end of this trajectory. The gray portion of this plot shows where we are heading with a baseline of current policies and technology forecasts. We're heading to a planet that's going to experience a 4 to 5 degree centigrade rise in temperatures relative to the Industrial Revolution. Our current policies and pledges and targets that we've seen over the past decade will take us to a future in which we might be able to achieve a 2.5 to 3 degree rise. And of course, breaking through that trajectory to a point of zero emissions in 2100 will take us to the 1.5 desired goal. I'm going to focus more on what we can do in the next decade relative to what can be achieved by the year 2100, because I think that it's more motivating and there's so much that we can achieve over the next 10 years. The Paris Accord had science-based goals and suggested that we need to focus on achieving temperatures well below 2 degrees C. And in fact, we should be pursuing the 1.5 degrees C. So this will require an immediate action of solutions, activation of solutions over the next decade. And the goal there to meet this science-based 1.5 degree limit is a 50% reduction of greenhouse gas emissions by the year 2030. So how are we going to do that? Well, it turns out that 22% of global carbon emissions are currently in locations where the governments have put a price on greenhouse gas emissions. And the same is true when you look at the United States. About 22% of our country, of the states in the United States, have put a price on carbon. You know, economists say that that's the very most efficient policy that can be used to motivate action in an effective way. About 20% of the world's largest firms have also embraced net zero targets. About 25 states have committed in the United States, have committed to meeting the Paris goal. And about 22 US states have climate plans. So you can see we've made progress, but there still is a great deal of action that's still required. I'm going to focus on the electricity sector because we can't meet these goals without decarbonizing our electric grid. And at the same time, this focus offers so many real opportunities. In a paper I published earlier this year, which you can find at that website, I reported on the forecasts of the International Energy Agency for the world, for global electricity, and the forecasts of the Energy Information Administration for the US electricity mix. And you can see going from the left, which starts in 2010, to the right side of the scale, which ends in 2030, that a great deal of progress has been achieved globally and in the United States. On the other hand, you can also see that by the year 2030, there is still a lot of fossil fuel left in the electricity sector. In fact, fossil fuels are forecast to dominate at about 50 to 55% of the fuel mix by 2030, unless we transform our policies and business activates its plans. So now, starting with the Drawdown Georgia project, I want to look at the global approach to global solutions that was proposed by Paul Hawken, who's an environmentalist, entrepreneur, a journalist, and an author who wrote and managed this analysis of where the opportunities are globally. He identified 100 possible technology fixes to meet a 50% reduction in emissions. And you can see that they span many sectors of the global economy, including not only looking at how we can emit fewer emissions from our energy sources, but also how we can use natural sinks such as coastal wetlands and oceans and land sinks to absorb the CO2 and prevent it from mixing in our atmosphere. So this was a wonderful compilation of solutions. You know, rather than focusing on the problem, this book turned to a perspective of opportunity. But it's unclear from a local lens which of these are particularly appropriate. So which of these would be appropriate to Saudi Arabia, which would be appropriate to a state in the United States? Well, for the past 3 years, I've been looking at what we might do to provide localized solutions using a systematic approach that anyone could use to sift through those 100 solutions and identify those that would meet the needs of a particular country or region or urban area. So we, on the Drawdown Georgia research team, ran the 100 global solutions from Project Drawdown through a series of filters, starting with relevancy. Which of these are relevant? So in order to know what's relevant, you need to know what the sources of emissions are in your country or your locality. So for instance, tropical rainforests was one of the solutions in the Project Drawdown 100 solutions inventory, but we don't have tropical rainforests and neither does Saudi Arabia. So immediately you will eliminate those that are just not relevant. And then you ask the question, which ones are market ready to be able to scale them over this next decade? So for instance, fusion would drop out, nuclear fusion would drop out. Maybe modular nuclear might drop out. Perhaps offshore wind in some circumstances might drop out, or perhaps it's nearly ready for your locality. Third, is there sufficient local experience and available data? So it takes all of this in order to put a major solution into action in a decade period. Can the solution deliver 1 million metric tons of greenhouse gas reduction by 2030? Now, we arrived at that threshold of 1 million metric tons because it's about 1% of the emissions of the state of Georgia. So as you look at your locality, your city, your country, you'd want to know what the total emissions are and where those emissions are coming from in order to know which solutions would be able to meet a significant threshold. We can't spend our time on little things, although all actions, of course, that are feasible should be pursued. But at a large scale, we've got to reduce to the real likely winners. And then, are they cost competitive with other solutions? So is it viable to think about electric vehicles, for instance? Do they cost much more than their competitors to buy and to operate, to maintain and to secure? And then finally, we asked the question, are there any other impacts of each of these 100 solutions that would be concerning or that would motivate us to look in particular at them? So some of these other impacts would include jobs. Do we have the labor force? Are we going to be creating jobs in areas that we can secure employment? What are the other impacts on the land and water? What are the impacts on equity and equality and on health and human well-being? So all the sort of beyond carbon impacts we took a look at. And the result of our analysis was a selection of 20 high impact solutions for the state of Georgia. Well, how did we get there? We walked through an analysis that first asked, well, what's the baseline forecast? What is the official forecast for these technologies? So how much rooftop solar is anticipated if we, in the absence of any new action? And then we go to the other end of the spectrum and ask, well, what's the technical potential? So for instance, if you were to put solar panels on every building in your locality, what would be the maximum achievable carbon reduction? And the achievable potential is somewhere in between. So this is a realistic scenario that considers the cost impacts and the stakeholder acceptance and consistency with a greater commitment to success. So for instance, we selected a threshold of perhaps 15% electric vehicles in the new sales inventory in the state of Georgia by 2030. A growing large-scale solar industry, meeting instead of 1%, up to 11% of the electricity in our state. So that's the systematic approach that we used to arrive at our 20 solutions. And here are the 20. I'm not going to talk about all of these. I'm going to pick 5 of them that I think are particularly transformational and applicable to Saudi Arabia and other localities. Large-scale solar, demand response, rooftop solar. You talk about retrofitting and electric vehicles. Putting all of those 20 solutions together in this diagram of emissions over time shows that for my state of Georgia, we would have the opportunity to drop our emissions from 156 million tons in the year 2005 to 79 by the year 2030, which is a reduction of 49, and that ends up equating to a 50% cut in emissions in the state of Georgia by the year 2030 relative to the year 2005. So we're very pleased that we had a plan that ended up being consistent with meeting our fair share of the Paris Accord. So let's turn to some of those key technologies in the area of electrification that were so impactful and so generate such optimism, resilience, and business opportunity. Just wanted to emphasize that electrification of the economy is a focus of many today. It certainly was a focus of the book that I highlighted in the last slide that was published a few years ago in 2019 in collaboration with Scott Valentine and Benjamin Sovacool. Scott is in Japan, Benjamin is in England, and I worked from Georgia, and we put together this sort of global look at the great energy transformation. And electricity was the star of the show from so many different perspectives. From the standpoint of how we might transform our fossil-based electricity generation system to one that was less carbon intensive, rooftop solar and large-scale solar were seen as the biggest impacts, the biggest opportunities. This is a picture of a 55 megawatt solar system in the state of Georgia, which is up and running today. So how many of these can we place in the state of Georgia by the end of the decade? I'm sorry that I didn't put a map of the United States. In case you don't know where Georgia is, it's in the southeast corner, just above Florida. I'll bet most of you know where Florida is. We have a border that's shared with the state of Florida here. And Florida, as you know, is the sunshine state. And it turns out that Georgia has a lot of sunshine too. So we felt that the high rate solar radiation and the affordable land within the state of Georgia was perfect for a significant boost in this solution's contribution to carbon reduction. But on the other hand, we do have to deal with the waste, the photovoltaic waste, and opportunity to recycle, and adverse land impacts, such as impacts on biodiversity that we need to consider when we're upscaling this solution. Now, rooftop solar. So if we go back, memorize this set of colors and go back to this set here. So you'll see the solar farms are available most economically in the rural parts of Georgia. In the urban parts of Georgia, we have the opportunity for rooftop solar. So I found that fascinating to consider what portions of the state are likely to benefit from investments in these two different types of solar systems. So most of the existing capacity is in large cities, is where buildings are, in Atlanta, Georgia, Savannah, Athens, where the University of Georgia is located. Atlanta is where the Georgia Institute of Technology is located. Here is Atlanta, and there is Athens. So again, we do have problems in that there are procedural issues when you go to try to put a rooftop solar system onto your house. You have to go through a set of permitting and assessments. The cost of every single household is can be difficult and made easier through bulk purchasing. So we have the opportunity for bulk purchase systems and delivery to make a difference. Now turning to what we can do in retrofitting, particularly in conjunction with demand response. Now, one of the most exciting areas of electric decarbonization is to combine the reduction in energy use with the modification of time of use consumption. So retrofitting with demand response is a winning solution. Here in the state of Georgia, we don't have a lot of demand response. That is, we don't have many of our appliances that are managed in smart ways. We don't have enough smart meters, and we don't have enough of the power electronics set up in order to manage a household's energy system. So here you need a smart thermostat. And here we have our storage devices. We have water heaters and electric vehicles being managed centrally to be able to reduce loads when electricity is most expensive, and also at times when that electricity is most polluting. It turns out that expensive electricity tends to be the most polluting because it's when consumption exceeds available sources, and you have to turn to the less appealing fossil fuels, typically the single cycle natural gas systems, for instance, those that are still using diesel. They're the ones that get triggered when you meet peak demand. And then finally, I wanted to highlight the role of electric vehicles. As we all know, this is a great opportunity for transforming our electricity system in ways that help to manage resilience. So here I focus on the need for charging stations and also for smart management so that those who are delivering your electricity can also trigger the charging of electric vehicles to complement of excess available power. So again, smart use of electric vehicles is a great way to enhance resilience and to achieve carbon reduction. So how do we achieve speed and scale? The speed and scale that's necessary. This is a book that just was published a few weeks ago that speaks to speed and scale. John Dower is the author of that. Just a few slides about what we're doing in the state of Georgia. We are tracking systems, tracking emissions, engaging with business, and activating solutions. So by tracking emissions, I mean that we're creating emissions panels, emissions dashboards to provide local information to decision makers. So we are launching in February a very extensive dashboard online system of information. They'll be available to all. Publicly available emissions information is a great way to move the needle. If you don't know, if you don't know where your emissions are today, you'll never be able to reduce them going forward. Second thing is that we're working with businesses, and we've created a climate business compact in order to do that. We have 18 members so far that have signed up, and some of these are ones that you might recognize, for instance, Google and Delta and Coca-Cola. I'm sure you know about them. So we're engaging them in common, in helping to meet compacts of reduction of carbon in their operations in the state of Georgia. And then finally, we've engaged in a whole bunch of action plans and activities. And many of these involve our students. So for instance, we have videos that were prepared by 9 teams of 50 Georgia Tech grad students. We've done research to action seminars, putting our students at the podium and having business leaders be the discussants. So let the students provide their ideas and analysis, and let the business leaders reflect on what they're hearing. We've also created a game. It's the climate reduction game that will be made available soon. And we've conducted a survey of what people think about climate solutions in the state of Georgia. We need to understand the consumer's perspective in order to know what will work best. So there are many ways that you can stay engaged with what we're doing in this drawdown project. Here are a couple of great sites that you can explore. They're up and running and have a lot of information on them. And we welcome feedback and input, which you will have an opportunity to provide at those sites. And I wanted to thank the KAUST team for allowing me to speak today. And in particular, I wanted to call out Abdulaziz Murtada, who had arranged for my speaking today. I hope that you have some questions for me and look forward to staying in touch. Thank you so much as we all try to meet our global obligations.
Thank you, Professor Brown. We do have a Q&A session. And at this point, I would like to invite the in-person attendees. If you do have questions, we do have 2 standing mics. And we have some questions online, so I can read some of those questions that are online. And in case if anybody would have questions, please make your way down to the mic. So thank you so much for your talk. We've really learned a lot about the different framework and the systematic approach to the drawdown from the Georgia perspective. So just wondering in terms of clean energy transition, because you use Georgia as the state of Georgia as an example. So wondering if it's more in terms of other countries, like for instance, if small countries, I mean, of course, maybe not applicable for Saudi, which is a very big country, but for small countries like Singapore, where I come from, Bahrain, Maldives, or autonomous cities like Hong Kong, if they are considering transiting towards clean energy, and that's currently the general consensus of clean energy, the best option would be solar and wind energy, do you think these small countries would, have a fair chance of transiting towards clean energy, given how small the land mass is for those small countries? And if not, what would be the best option for them then?
So I guess the question came from someone from Singapore, which of course already is such a leader in clean energy. And I am sure that with their experience and expertise, scientific expertise, these goals would be achievable. They are, of course, land constrained. I've been to Singapore, spent about a month there at the National University of Singapore looking at such things. I'm not entirely sure about offshore wind. I hope that their seabed around Singapore might be able to support offshore wind. I know we're looking closely at that all around the United States. That's a very offshore wind, onshore and offshore wind, of course, are very important as a national technology for the U.S. I would think that those would be great opportunities for island nations such as Singapore. I know that solar farms will not be, because you don't have the land to support that. You don't have the expanse that's needed. There are interesting ways of, through light pipes, of bringing solar down into underground, for instance, agricultural systems. So some of that could be explored. It does require that you use your rooftop or other platforms to concentrate the sunlight. So again, land is still an issue, but might be possible.
Right. So in terms of, for instance, some of the questions that are talking about the clean energy, and like the top upvoted question that is comes from Marsha Dix. I hope I get your name correct. So he says, he or she, how would localized drawdown solutions be funded? Do you believe the majority of the costs should be carried by industries or by citizens? And do you think this could lead to economic discrimination against low-income households? Because usually when you impose even a carbon tax on the industries, the cost then gets transferred down to the general consumers. So do you think this can possibly lead to economic discrimination against low-income households? And if so, what can be done about it?
Well, that's a wonderful question. I'm so glad you brought up the issue of equity, which is first and foremost in my research these days. My work on carbon tax and dividends is focused on using those tax revenues to recycle them back to households. So the household sector receives the revenues from the tax and dividend approach. And there, while the rates of the electricity sector rise when it is taxed, I've looked and done the calculations and done the modeling using very sophisticated programs that the low-income households' net electricity bill will not rise if they receive those revenues in return, if it's a net revenue neutral approach. So I'm optimistic that the carbon tax could be designed very fairly. In terms of what programs you could use to try to motivate the adoption of individual solutions like electric vehicles and heat pumps and retrofitting of buildings and solar rooftops, these are all very expensive and less manageable to those who are income constrained. So I really am supportive of the electric power companies offering on-bill financing so that the household doesn't have to pay up front, but can pay through their energy bills. So the financing is done by the energy company, and the household remuneration occurs through the energy bill. You can make it such that the energy bill never increases over time, even with the additional upgraded products.
So in essence, there are many multiple ways to make sure that if a carbon tax were to be imposed, that there are ways to transfer and alleviate some of the costs that may be transferred to the low-income households. But then the key approach is that the policy decisions has to be fair and equitable as well.
Yeah.
So let's say, for instance, what are your thoughts on a carbon tax? Do you imagine that working in that carbon tax to work in a fossil fuel-based economy like Saudi Arabia? Of course, Saudi Arabia is also gradually transiting to clean energy, but it's going to take some time. But do you think in the immediate short-term period that imposing a carbon tax on a fossil fuel-based economy like Saudi Arabia would be a way to perhaps accelerate the process of moving towards clean energy?
I do. Carbon taxes, again, are seen by economists as the most efficient way to ensure that the environmental costs of consuming, combusting fossil fuels are priced, and through higher prices that are proportionate to those emissions, the fossil fuel providers are motivated to look toward the less emitting options, which could be a combination of energy efficiency, if they can be rewarded for making the consumption of energy lower in buildings and in even in the automotive industry with more efficient automobiles. Doesn't have to be, you have to go to electric vehicles to make a significant impact in transportation emissions. Efficiency is a big way to go to. And of course, with gas guzzler taxes, which in a sense, a carbon tax would be a gas guzzler tax because prices of gasoline and diesel would rise, and if you had a large guzzler car, then you'd be paying much more.
Mm-hmm. So speaking about fossil fuels, it seems that from your slide, you show that there's going to be a dependence, there's still going to be remaining a pretty high percentage of dependence on the fossil fuels by 2030, at least I think from one of the earlier slides that you've shown just now. So I guess the fundamental question is, why are we as human beings or modern society still so addicted to fossil fuels? Is it because of infrastructure limitations, or what is the underlying problem behind this addiction to fossil fuels?
Well, you're absolutely right that there are a lot of infrastructure issues that maintain our addiction to fossil fuels. And the transformation to a new and modern economy is going to have to require many new types of infrastructures. And I showed you pictures of charging stations. You can't roll out an electric vehicle fleet if you can't provide for the charging infrastructure needed. And for solar, the widespread availability of broadband infrastructure is needed. You've got to have 24/7 Wi-Fi in order to manage your rooftop solar systems. So that has got good high capacity interoperability is required. So there is a whole upgrade in the infrastructure, which is good for a lot of parts of our economy and good for the future and for resilience. So you hit it on the head with respect to infrastructure.
Right. So infrastructure in the sense of physical infrastructure, like if you want to push for electric cars, the electric charging stations has to be as commonly available as driving to a diesel station to refuel. So accessibility and convenience are very important to break that addiction. In addition, there's also the digital infrastructure that has to be built up as well to facilitate the transition towards the clean energy sector. Is that right?
That's a great summary. Thank you.
Mm-hmm. So what do you think about the future of e-fuels for transportation and the future of research on the life cycle assessment of e-fuels? Because actually the students, they've attended one of the talks, one of the first keynotes that was done was by Professor Arpad Hovav in the University of California, Berkeley, and he mentioned about life cycle assessment. And so I think this is kind of a follow-up question on what do you think about the future of life cycle assessment of e-fuels?
Mm-hmm. Yeah, so life cycle assessment is really an important framework. We all need to consider the full impacts of our fuel choices. So, one of the big debates is whether an ethanol or cellulosic ethanol, next generation biofuel, might be a good substitution. And there you've got to look at the full life cycle impacts. For e-fuels, there you've got to look at the carbon intensity of the electricity, and that's where the electrification of the transportation sector has got to be done in conjunction with electrification, decarbonization. They've got to go hand in hand. I've done modeling where I've put a carbon tax just on the electricity sector and not on the full sector of transportation and industry, et cetera, and simply electrifying, decarbonizing the electricity sector has a lot of successive benefits to other parts of the economy too.
Right. And so speaking about some of the earlier sessions that our students have attended, we also have Dr. Jonathan Foley from Project Drawdown. He actually gave one of the talks on the Project Drawdown. So I hope that when they listen to your talk about Drawdown Georgia, that they remembered about the Project Drawdown that was in one of the few earlier talks. So And we also have Bernice Norton-Boom, who's a climate journalist and an Arctic explorer. So we've basically asked both of them about whether are we moving towards the right track in terms of climate mitigation and what are their thoughts about it. So I would interpret both of them have quite contrasting opinions. So for instance, Bernice was saying that yes, we are moving in the right direction, but perhaps moving a bit too slow. And Jonathan was a little bit more optimistic, and he was saying that we still have time, but we need to start doing some stuff. We need to start doing actively, but we do still have time. So what are your thoughts about it? Like maybe you can try to provide some perspective on, are we moving in the right direction globally? And do we still have time, or we really need to start accelerating and do something much faster?
Yeah, I'm so glad that you had Jonathan Foley speak. That's terrific. So when you get to a package here of two talks that are very compatible. We're going too slowly, and I think most analysts I work with agree to that. One of the questions is whether we should be pushing forward on carbon sinks faster. And there's quite a debate about whether that would be a morally acceptable. Because if we do trade-offs, such as purchasing offsets for the planting of trees to enable an individual or a business to continue to emit, you have to ask whether that's sufficient. You know, shouldn't we be doing all that we can and also expanding our forests? So I think the role of negative carbon emissions is really one that's worth debating. I don't know if you had any speakers that talked about those options, air capture and offsets. I'm for efficiency first approach and complemented by renewables.
Right. That, I mean, you brought a good point. I think there has been an increasingly strong emphasis on carbon sinks, and sometimes perhaps an overly strong emphasis on carbon sinks might be diverting the attention as to the fact that we need to reduce the carbon emission in the first place. Right?
Yeah.
Because it might, I mean, in the essence of creating those carbon sinks, we might also be generating carbon emissions, especially in certain areas where you need the water to create that carbon sinks. And getting that water will generate carbon emissions as well. So I think that there is indeed a potentially over strong emphasis on creating carbon sinks, but without understanding the whole appreciation of carbon sinks needs to offset the carbon emissions in the first place. So,
that's a good summary.
Yeah, so continuing on the question, and I think you've mentioned multiple times about the need of energy efficiency, and you are a strong proponent of energy efficiency as an important element to achieving energy security. Can you tell us a little bit more about how establishing smart grids in the cities of the future can help in maximizing energy efficiency?
Yeah, energy efficiency requires that the basic energy consuming equipment in buildings be more efficient. And of course, management systems to do that have to be smart. So you need to have internally an investment in better management technologies, so especially in commercial buildings and hospitals and banks, you know, large office complexes. They need to have professional managers, or at least very sophisticated software management systems. And that's so that the efficiency of the consumption is optimized. And then layered on top of that, you want to be sure that the energy use is managed so that it's compatible with the efficient delivery of electricity from the generation complex. So you have managers in our control systems, in power plants, and in what we call balancing authorities. It's the individuals that are responsible to be sure that demand is met, by supplies in an instantaneous fashion, and this is ever shifting. And we've got this new term. It's we've got to shape and shed, shift and shimmy. We got to be looking at how we use energy at a long contractual kind of standard, all the way down to our daily and hourly and microsecond scale. So that allows the whole complex of electricity provision and use to be optimized and to be made most efficient from a sort of structural and systems basis. So we've got lots of efficiency at many different scales and being controlled by different organizations and individuals. So it's a really an exceedingly complex challenge, but I don't think we should be concerned with not having the solutions. We need to be concerned with getting the solutions into place.
Sure. So if you were to, right, so if you were to grade the whole, in the global sense, if you were to grade the different regions across the different world, how would you grade the achievements across the different regions in terms of what they have been doing in implementing the clean energy programs? Is there any particular region across the globe that perhaps needs to do more to push that transition towards clean energy?
Well, those that I would award for their contributions to date would include the Nordic countries, because they have done so much with both renewables and electric vehicles and the vehicle to grid connection. They are really at the leadership position. The United States is not doing well. We're not doing well enough. Need to do much more, and increasingly that's been recognized. I've always looked to Japan, Korea, Singapore for solutions on the energy efficiency, and Germany. Northern European countries have done so well with efficiency, although they have gaps as well. I've written about the lack of smart meters, for instance, in the country of Germany, and as I understand it, there's a concern for the management and protection of information. People are not wanting their personal information on energy use to be shared. So we have to figure out how to work around some of those issues. Gee, I don't know. I think every country, every continent can do better, and all of them have areas of expertise that make them leaders. Right. So it's a wonderful opportunity to pull all this together. I hope that I'm so glad that your conference has brought in leaders that are sharing what they've learned.
Well, we hope to inspire the next generation of leaders to think about what we have discussed over the past 1 week and also for the next week as well. So I guess we can maybe switch a little bit in terms of the direction of the questions. It seems like you have a fan with Salim. He's asking that you have 9 books, based on the introduction that I've mentioned just now, which is quite a lot of books. So do you enjoy writing books, and which one is your favorite book writing experience? Where do you draw your inspiration from? Those are basically books about your research areas, right? And what is the motivation behind writing those books? Is it because you want to do a much better outreach to tell people that this is a major problem and that we need to do something about it? Like, what drives you to write all those books? Because it takes time.
It does. I spend summers writing books. The books come somewhat easily because I teach large classes of graduate students at Georgia Institute of Technology in these areas, and I take my lecture notes and I expand on them and move them into, book form. So it's what I don't have are some of the great designers, and so let me just show you this. Here's my book. Oh, let's see. So here's my latest book. It's got a great, it's got a great cover,
Yes.
but it doesn't have a lot of color inside. It's got a lot of tables and has some nice diagrams. Now this is the book I was mentioning, Speed and Scale. You look at it and you see just fantastic production of graphics and storytelling, and this is the sort of thing that moves markets. This type of book, as does Jonathan Foley's book. So one last one, if I can find it. Maybe I can't find it. Oh, here we go. Okay, Paul Hawkins' Drawdown. The great thing about this is that every other page is a wonderful drawing or photograph from somewhere in the world showing solutions in action. So I hope this wasn't too unconventional, jumping up and down.
No. But it goes to show that sometimes it's not just about writing, it's also about the visual impact. Just like what Bernice was mentioning in her talk, that seeing is believing, and sometimes you really need to make the visual impact to convey your story as well.
Yes.
Yes. And the same person, Salim, he or she was mentioning, about how do you manage your time in having been a professor at Georgia Tech and as a joint faculty member at Oak Ridge National Lab? Obviously, that means a lot of your time, plus writing books. So how do you manage all this time? So why would you want to have two positions, for instance? I mean, of course, a joint position perhaps require less of your commitment, but why would you want to hold both positions rather than choosing just a single institution?
Well, Oak Ridge National Laboratory is the largest energy research lab in the country, and its impact is not just national but global. So I wanted to reconnect with Oak Ridge, having previously worked there, to see what they were doing, be able to stay in touch with some large science projects, and also to leverage so that the work that I'm doing can be expanded from a state of Georgia focus now back to a national and larger regional focus. It is important, connections in one's career is so valuable. My advice to my advisees, my students, is that relationships are important and need to be nurtured. If you have a favorite professor now and you graduate next year, stay in touch with them, send them messages, tell them what you're doing, because this sort of networking and relationships are so important.
Yeah, I agree. It's important to maintain the relationship and the connection and keep in touch with your advisors over time, and not just say upon graduation, bye, and that's the end of the story. So maybe the last piece of advice that you would give to the students who are attending today's lecture, for instance, those who are particularly motivated to do something, do something maybe in their field in terms of water, energy, food, or whatever, to mitigate the grand challenge of climate change and therefore achieve resiliency in our future. What would your final advice be to them?
Well, continue to hone your science and technology skills, because you are going to be the messengers that will bring science to solutions to the business community, the communities of agencies and households and individuals across your country. So I would say just keep your skills sharp so that the messages you bring are sound and motivational.
Thank you so much, Professor Brown. Thank you so much, and thank you. Bye.
Thank you very much for having me participate. Appreciate it.
Now there is massive amount of opportunities into different industry, EdTech, health tech, biotech, and many other areas that are really great opportunities for entrepreneurs to capture. As we live through the pandemic, those kind of shifts create those cracks into different industries that creates opportunities.
The key aspect that I think all of us need right now, which is a key aspect of resilience as well, and that of course is hope. Hope that things will get better, hope that we can make it better as well.